row. All right, you guys. Okay, so hello, you people.
Hello.
Hey.
Hello, all those people in YouTube land. Okay. What'd you say? Rosh Hashanah?
No.
What?
That's
I know, I heard that too, right? All right. Okay, anyway, tangent lines and parametric. So there's a couple things. It's super easy. When I said it's easy, it's very easy. So think of it as like L'Hopital's. And so it's the derivative of the top over the derivative of the bottom, right?
Yeah.
Okay, basically. So definition of smooth curve. That's important. Smooth curve. Let's see, denote a plane curve represented by the parametric equation. X equals x of t, y equals y of t in between a and b. Suppose each function is continuous on the closed interval a to b, differentiable on the open interval a to b if both dx dt and dy dt are continuous, are never simultaneously 0 on AB. That means, you know, that both derivatives are not 0. Okay? Then C is called a smooth curve on that closed interval. To find the derivative, it's derivative y over derivative x.
Yeah.
Yeah?
Yeah.
Provided that dx dt is not equal to 0. Because that would be undefined. We don't like that. Okay, so a number where dx dt equals 0 but dy dt equals 0. That means I cannot have the derivative 0 over 0. I cannot have that. Okay? Cannot have that. So that's the point that we're trying to make. The smooth curve, and C has, so this is going to be 0 but y is not 0. We get a vertical tangent line, right? Vertical, straight up and down. A number where dy dt is equal to 0, but the bottom is not, smooth curve has a horizontal tangent line. So that is a horizontal line, right? And we're going to be dealing with a lot of curves, so we're going to be dealing with this. Find the equation of the tangent line to the plane curve with parametric equation, blah and blah. Okay, first thing I got to do is what? Yep, let's do that. Take the derivative. So on your notes right now, on your paper, okay, you are going to take the derivative. So the derivative is dy dt over dx dt. Okay, so that is the equation of the tangent line. When am I dealing with this? When is this? When t is 1, right? So when t is 1, I get 1 over 3, right? Okay, so now I'm going to make an equation. So let's go ahead and plug in this to figure out my x value. Plug in 1 here, I get
3.
Plug in 1 here, I get
2.
So I get y minus 2 equals 1/3 x minus 3. Yes?
Yep.
Okay, so what do we come up with?
Y equals 1/3 x plus 2. Oh wait, I'm sorry,
Minus
no, 1.
1.
And then plus 1 though? That's plus 1.
Plus 1? Thank you. Plus 1. It's all right. We're still early.
Yeah, I'm sorry.
Trust me. Yesterday I was the same way with this. I tried to math yesterday morning, and yeah, it wasn't looking good. All right, so let's go ahead with part B now. On part B, it says find all points in a plane curve in which the tangent line is vertical. All right, what do we say about vertical lines?
Yeah.
Say it. dx dt is equal to 0, right?
Yeah.
Okay, so I need to have dx dt equals 0. So I'm stating that now. So it's going to be 6x equals 0. So x equals 0, right? Now, what is the stipulation to go along with that? What is stipulation? It's on the notes. Something else has to happen. Very good. dy dt is not equal to 0. That's what I need. So, when x is 0, okay, what'd I do here? Dang it. I'm like, I'm crying. All right, so 6, t equals 0, t is 0. So now when t is 0, plug it in here. Okay, so dy dt is 2. So when t is 0, this is 2. Right? Okay, that's what I needed. That's what I needed. So this is 2 when it's not. So now, okay, find all points. So my point is when t is 0, right? Plug in t 0 here, we get. Plug in t0 here, we get 0. So I only have one point in which this is going to have a vertical tangent line. Easy? Yep. Okay. So I like derivatives.
It's back. It's cycled back.
Guess who's back? Back again. Show that the slope of the tangent line to the cycloid is given that. So, the slope, that means that dy dx is sine of t over 1 minus cosine of t. No, this is the derivative, right? So I want to make this, into this, right?
Yeah. Well.
Or actually, I'm sorry, here it is, there, over here.
Yeah.
So I want to make this into this. So if I do that, I'm going to say that A, right? So as I do this, A minus A cosine t brain work, come on, A cosine of t, right? So this is the y of t. Now the dy of that would be what?
1 minus, well, I mean,
It's in terms of t, isn't it?
yeah,
So that means that the a is some constant, isn't it?
yeah, so we can just,
So that piece just goes away.
yeah.
That piece is just going to go away. So now, because of that, the derivative of negative cosine is positive sine, right? Say yes. So this is going to be positive sine. So it's going to be a sine of t. And what else does that mean? What else do we know? A equals?
0. No, A is greater than 0.
It's greater than.
So A is
1.
1. A is 1. Because I needed it here, right?
Yeah. Emerald's gonna need to be 1.
Yeah, I'm going to need it down here also.
Yeah.
Does that make sense? Because I'm taking I'm just proving that this is going to be the derivative when A is 1. Alright, I'm going to clean this. Now I have to do the same thing for my dx. So it's going to be A of t, or I'm sorry, AT minus A sine t. So the derivative of AT is,
1. Well, it'll just be A, but A.
okay, it's going to be A, right?
Yeah.
Minus derivative of sine.
Well, it'll just be cosine.
Yeah, so this is going to be cosine, right?
Yeah.
A cosine. Cosine t. And again, in this case right here, A is 1. So by showing that, I've showed that A had to be 1, and then I got the derivative to come out to be there. So yeah, show that the slope of this is this. Okay, so now I have that function. Yeah? Okay, so now I have a function for this, right? Now I have a function for this. So now I have to find any points in where that the tangent line to the cycloid is horizontal. So if that's going to be horizontal, what does that mean?
Y.
The y,
Zero.
dy is equal to 0. So that means I'm going to set sine of t equals 0. And my interval is going to be from 0 to 2 pi. So where is that going to be equal to 0? Only where? Only at pi. So it's basically t equals arc sine of 0, which we get t is pi. Yes? Okay. Now, I'm going to show you guys this neat little trick with your calculator. So, what mode's your calculator in? It's in degrees. Leave it in degrees. Leave it in degrees. And this is what I show with my trigonometry students. So they do all this all the time. But instead of using all the rules and everything, I show them a neat trick with the calculator. Because it only works in degrees. It doesn't work in radian. Because radian gives you decimals. I want degrees. So I'm going to go here. And I want my function sine, right? In this case, sine of x, right? Say yes.
Yes.
Okay, sine of x. That's the only thing I'm dealing with. Hit enter. Now, I'm in radian.
Yeah. When it's in degrees, it's straight.
Okay, so. Oh, wait. I'll show you guys how to do this also. Watch. So, I totally forgot. Okay, right here. On sine, put a degree sign. If your graph is in degrees, put a degree, or radian, put a degree sign. Now, what is my window? What is my interval?
From negative 10 to 10.
Nope, try again.
What do you mean?
What is it supposed to be?
Well, 0 to 360.
0 to 2 pi. So in degrees, that's going to be 0 to, very good. So it's going to be 0, and it's to 360, right?
Yeah.
360. Okay, hit enter. Bam. So right here at the end, it's equal to 0. Over here, it's equal to 0, and right here. So let's menu, analyze, 0. So my answer is 180. So in degrees, that's 180, isn't it? In degrees is 180, but in radian that is, it's just pi. Do you guys remember how to convert a degree to radian? Yeah, so you take your 180 degrees and you multiply by pi over 180.
Yeah.
Okay? And you would do the same thing to convert from radian to degree. So if I want to go like pi over 2, and that's going to be times, so it's the reciprocal. So I want to go from radian to degrees, so let's go 180 over pi. Equals 90. So it's a neat calculator trick to help you guys if you guys get stuck on a calculator part. Because a lot of times you're going to be like, oh crap, where does that lie? Okay? Just figure it in the calculator and then you can actually do the math for the radian. You can convert it back. So you get something like pi over 12. You're going to end up something like that on one of your tests. So pi over 12, okay, so that comes out to be like 15 degrees. So 15 degrees is going to be one of the ones that you're going to have to deal with later on. Anyway, so we get sine is pi, right? So is there any other places?
Yeah, not on the
Okay, so now, but what has to happen for it to be horizontal? I get this is going to be right.
Yeah, but dxdt can't be
Okay, so dx dt. So let me see. I get what is 1 minus cosine of pi is,
0.
what's cosine?
Oh, it's 1.
At pi, negative 1.
Oh, sorry.
2.
So it gives me 2 on the bottom, right? So does that one work?
Yeah.
Yes, so that one does make it work. So my derivative, I do not get 0 over 0, and I get the point when t is equal to pi. Okay, so I found all the points where it's going to be a horizontal tangent. Find the equation of the tangent line to cycloid, the points found at B. So now, if t is pi, right? Yes?
Mm-hmm.
Okay, so now let's go through. So we know that point it's going to be equal to, the slope is what? Slope is what? What's the slope here? Horizontal line.
0.
0, thank you. The slope is 0. Horizontal line, slope is 0. Yes?
Yes.
Okay, slope is 0. So I know I'm going to have y minus something equals 0, quantity x minus something, right? So I need to plug in this into my original functions, right? Plug in pi to my original function. Okay, so this is the derivative. This is the derivative. So I don't want to plug it in there. I have to plug it into the original. So let's see. And we know that a is 1. So that means that this is going to be sine at pi is 0. So this is going to give me, so it's going to be, say pi. Yeah. So because it's 1, right? Parentheses pi minus sine at pi is 0. Okay, do the same thing for this. Same thing for this. So it's going to be 1 parentheses 1 minus.
Negative.
So that's going to give me, what do we say?
Negative 1.
Negative 1. So that's going to give me, let me see, what do we get? 2. I get 2. So my point is going to be pi comma 2. So 2 and pi. So for this one right here, I'm going to get y minus 2 equals 0. So y equals 2. Questions? All right, so for this right here, find the plane represented by the parametric equations. I'm sorry, the plane represented is here and here. Crosses itself at point 0,4, also has two tangent lines shown in the figure. Find the equations for these tangent lines. There. Okay. So I unfound them. You guys didn't see it.
Yeah,
right.
I know,
Did
right?
anyone take a picture of it with their brain?
I know, right? It's almost like you have it on your paper already. Anyway, so we're going to do the math for this. So I know that both those cross, right? Say yes.
Yeah.
Okay, so they cross, so that's going to be equal there. So let's go through, and since I'm trying to find the tangent lines, so let's go through and start off with the tangent. So, do I have it on another page? Ah, crap, no. Insert page. Okay, so what was it?
X of t equals t cubed minus 4t.
3t cubed or t cubed?
It's just t cubed minus 4t.
4t?
Yeah.
And?
And then yt equals t squared.
Okay, let's do derivative. So it's going to be dy dx is equal to 2t, right?
Yeah.
Over
3t squared.
3t squared minus 4. Yes?
Yep.
All right, so now I need to try and figure out where, when these two things, so they're both going to cross at certain points, right? Yes?
Mm-hmm.
Okay, so right here, I need to see when is this one going to be equal to 0. Because I have that already, right? That point.
Oh yeah, it should tell us 0.
Yeah, so I'm going to have that point 0. So let's see. So I'm going to have this going to be 0 equals t3 minus 4t, right? Yes?
Yes.
Okay, so right here, then I'm going to have, so I know my points are going to come out to be here. So let's go ahead. I'm going to get, factor out a t, and I get t squared minus 2, right? 4, sorry. I was getting ahead of myself. So from here, I'm going to get t, parentheses, t plus 2, t minus 2 equals 0. So I have points where? 0, -2, and 2. Okay, so there's my points. Now the next one, I know that this is going to be 4 is t squared. So I'm going to get that t squared minus 2. Ah, crap, why do I keep doing this? Brain. I know. You better work. There we go. Okay, so I moved it over so I can factor it because I like factoring. All right, so I get 0 is equal to t plus 2 and t minus 2. So I get, oh crap. T,
I think this calls for a break.
nah, I'm almost there. I'm almost done. Okay, so I get -2 and 2. All right, so now, which ones do they have in common?
-2 and 2.
-2 and 2. So those are the places in which that I'm going to actually have these equations be the same. The 0 is not going to count. For this one, it's not going to be there because the y's isn't going to work out either. So let's go ahead and plug it into my derivatives. So when I get here, so -2, plug in -2 here, I get -4. So right, it's going to be -4. I'm going to clean up my mess. Hold on, I'm going to clean this up so I can make it a little bit easier. There we go. All right, so it's going to be negative 4 over, this is going to give me 4, right? 12.
4 is 8.
Okay, so I get 8, which is negative 1/2. All right, now do it again for the positive 2. For the positive 2, I'm going to plug that back in. So it's going to give me positive 4 over positive 8, which is a positive 1/2. Now that I have my slopes, I know my points already, right? So my first one is going to be y minus 4 equals negative 1/2 x minus 0. Because that's my x and y, right? From my original function where those two intersect. So I'm going to get y equals negative 1/2 x plus 4. Now let's plug in that positive. So y minus 4 equals positive 1/2 x minus 0. So I get y equals positive 1/2 x plus 4. Easy now? Okay, yeah, I'm not ready for this one yet. All right, so I'm going to pause there. We're going to take a short commercial break. Hello. All right, here we go.
Good thing they didn't hear that.
Oh no, it's been recording the entire time.
Okay, so Newton's first law of motion. Anyone?
For every action. For every action, there's an equal and opposite reaction.
Is that the first?
Or is that the
Which
third?
one's the one with the friction?
But the first is
Object in motion?
state of motion.
Yeah, friction.
Yes, there we go, see?
Inertia. First is
Yeah, there we go. Anyway, all right, projectiles fired at an angle of theta, and theta's in between 0 and 2 pi, right? Because it would suck if it's anything more than 2 pi, right? Oh yeah, pi over 2. It would suck if it's more than that, right? Maybe?
Yes.
Yeah, I got a nice video. Yeah, I got a nice video of someone trying to do a water balloon launcher, but had a watermelon in it, and then, yeah, it launched at, I would say probably 5 pi over 6. Yeah.
What does that even mean?
Okay.
That's about.
Yeah, so, anyway, I'll show it later. All right, to a horizontal with initial speed of v sub naught meters per second, assuming no air resistance. The position of the projectile after t seconds is given by a parametric equation, v of t cosine theta t, and y equals v sub naught sine theta t minus 1/2 g t squared. Okay, t is going to be greater than equal to 0, where g is the acceleration due to gravity, which would be what? Anyone?
9.8 meters per second.
Yes, negative. So yeah. So huh? No, it's not.
We're in calculus now, boy.
I know, man. Seriously, this is not. Whew, just uses 10. That's like saying pi is 22 over 7. Ugh. Anyway.
No, it's
Alright.
actually
Wait.
4 times the sine.
Anyway, all right. Find the slope of the tangent line to the motion of projectile as the function of t. Okay. So, find the slope of the tangent line. So what do we got to do that? Very good. Kind of like what we did with the previous problem. So, take a moment. I want you to do the derivative, which would be dx over dy, right? Or dy over dx. Thank you. Sorry. dy over dx. Are you trying to figure out 22 over 7?
No.
Maybe.
I don't know what happened.
Oh.
You said pi. When I remember from the book. That's what pi is.
Okay. Find the derivative. Might be tuberculosis. Unless you're anti-vaxxer, and it might just be like common cold.
I don't think that's how it works. The anti-vaxxers are more susceptible.
You gotta go from the extreme to the.
In a way, I'm an anti-vaxxer. Don't get the cold vaccine because it always makes me sick. Do the math! Man. You know what? I'm going to pause this one because I'm, let's see. All right. So, slope of the tangent line. So, I'm going to do derivative of this. So, that would be what? So, what is my... So, this is in terms of t, isn't it?
Yeah.
So, my derivative, so my dy is going to be what? Of sine theta, right? Because theta is not my variable. So I'm not taking the derivative of theta. Right? And then it's going to be minus. T is my variable, right?
So
GT. Over right? That's not so bad, right? Because in this case right here, if you understand that t is the variable that I'm taking the derivative of, everything else is staying a constant. All right, so now, given this, at what time is the projectile at its maximum height? We're talking about derivatives now.
Yeah, so now we're going to do the first derivative.
Oh, we got the first derivative, right?
Yeah, so, well, okay. So
And do what?
Set it equal to 0.
Excellent. Set it equals 0. So if you guys remember, if I'm launching something, it's going to go up. I'm going to get a slope of 0. Then it's going to start coming back down. Okay, good. So let's set this equals 0. So let's do my math. So 0 equals v sub naught sine of theta t, right? Or just sine theta?
No, it's just sine.
And then it was plus, minus, is it minus?
Yeah.
So it's minus gt. All over
V sub dot cosine theta.
Okay, so what's going to happen here? So I'm going to get rid of my v sub naught cosine theta, right?
Yeah.
I'm going to get rid of all of that by multiplying both sides of the equation by that. So I'm still going to get 0 equals v sub naught sine theta minus gt, right? Yes? I'm setting it equals 0. So what am I trying to solve for now?
Theta. Well, there's also t.
What am I solving for? T, right?
Yeah, because we're all.
T is my variable, and it's asking for at what time. At what time? So I'm solving for the time on this case. So I'm going to have, let's see, gt is equal to v sub naught sine of theta. So t is equal to v sub naught sine of theta over g. We just algebra the crap out of this.
Yeah.
Now, we can go back with other things to find out when t is my maximum. So if I knew the gravity for that spot right there, you know that gravity is inconsistent around the world, right? It is inconsistent. Some places there gravity is more than others. So we just say G instead of using a number, or just using 10 U, or my velocity, initial velocity, and the angle that I'm launching this at, right? Okay, so I now, and for especially those people out in YouTube land, okay, I'm going to show you guys what happens when you have an angle greater than pi over 2.
Wait, is it legal?
Yes.
Is it legal?
Okay, so
Spelling with 2 L's.
No. It's B.
Oh
my god! You died.
So, never launch at an angle greater than pi over 2.
I can't feel my face.
Never launch at an angle greater than pi over 2. If I have scarred you enough, you will remember that right there. You will never launch at an angle greater than pi over 2.
Oh, that gotta hurt.
Okay. All right. Anyway, all right. Like, share, and subscribe.